Okay, so now we're going to learn about load balancing. So you may be asking, what is load balancing? Well, basically a load balancer is a server that will front your application and it will forward all the internet traffic to your instances of your applications downstream. Okay, so this is what it looks like. We have our EC2 instances and they have our application, and we have a load balancer a bit before that. Now, when the users connect, they don't connect directly to the EC2 instances. They will connect to the load balancer. So we have user 1 connecting, and the load balancer basically redirects that traffic to the EC2 instance. The EC2 instance comes back with a response to the load balancer, and the load balancer gives back the response to the user 1. Similarly, we can have a user 2 that will connect to another EC2 instance, and a user 3 that will connect to another EC2 instance. It's called a load balancer because, as you can see, user 1, 2, and 3 do not go to the same EC2 instance in the backend. Okay, the load is being balanced. So that's the whole idea behind a load balancer. So why would you use a load balancer? Well, you really want to spread the load across multiple downstream instances so you can scale your instances downstream, but still expose only a single point of access to your application. Similarly, if your downstream instances fail, we don't want our clients and our users to see that failure, right? We want the load balancer to still work. And so the load balancer will do health checks to our instances to make sure they're working fine. And if they're not working fine, it will redirect the traffic to the instances that are working. Also, the ELB, the load balancer, can provide something called SSL termination or HTTPS for your websites. That means that the termination and the encryption of the connection is between the client and the ELB, and then the ELB, or Elastic Load Balancer, goes and talks directly to your instances in HTTP traffic. It can also enforce stickiness with cookies, so that means that the user basically will talk to the same instance over time. And there is also a concept of high availability across zones. That means that your load balancer can run across many zones, and so do your instances, and that basically allows your application to be highly available in case an availability zone just fails. Finally, the last benefit is to be able to separate public traffic from private traffic. So don't worry, all these concepts we're going to do a deep dive on right now. So why would you use one? There is basically an EC2 load balancer called ELB, and it's a managed load balancer. And AWS will guarantee that it will be working. AWS guarantees that they will do upgrades, maintenance, and will maintain high availability. And AWS will provide a few configuration knobs for us to tune things up. And these are really, really nice because everything is managed from the UI. Overall, even though it costs less to set up your own balancer, it will be a lot more effort on your end, and in the end, the total cost of ownership will be much higher. So it's very, very common to use the ELB from Amazon. Finally, it is integrated with so many AWS offerings and services for monitoring, for compute. So there are different types of load balancer in AWS, and that can be confusing. There are 3 kinds of load balancers. There is the classic load balancer, or V1, or old generation. And this was created in 2009. So this is quite old. And then recently, there was something called an application load balancer, which is V2, new generation, which is 2016. And we had a network load balancer, V2, also new generation, 2017. And overall, it is now recommended by Amazon to use the newer /V2 load balancer as they provide more features. So we'll see how the features relate to one another. But basically, the application load balancer and the network load balancer is what is going to be asked mainly at the exam, although it's still important for you to know how a classic load balancer works. Overall, we can set up, thanks to your load balancer, an internal load balancer or an external load balancer, depending on whether or not you want your application to be exposed externally or internally. So let's first talk about health checks. Health checks are really crucial for load balancers because they really allow you to redirect the traffic to instances that are healthy. They will basically enable to know which available instances are to reply to request. And basically the health check is super easy. You just give it a port and a route. For example, /health is very common. And if the instance says, yeah, I'm okay, 200, then the instance is healthy. Otherwise, if it's not 200, then the instance will be unhealthy. So here's what it looks like. We have our load balancer and we have our EC2 instances in the backend. And it will do a health check on port, whatever you want, really. So 4567, but it could be port 80 or whatever you want. And it will ask for the root /health. And that's you who set up these things. If the EC2 instance says, okay, then it's deemed healthy. If it's not okay, it's not healthy, and the load balancer will stop sending traffic to that instance. So application load balancers are V2, And they're called layer 7. Layer 7 because they allow you to work at the HTTP level. So the application load balancers allow you to handle multiple HTTP applications across machines. And so we're going to group these applications in target groups. In the next slide, I have a diagram to show you. Also, we can load balance to multiple applications on the same machine, and that's containers. So that's a very common question at the exam. They will say, we need a load balancer, we need something to load balance across the same application running on the same machine. How do we do this? And the response is an application load balancer. Finally, you can load balance using the root in the URL, or you can load balance based on the host name in the URL. So they allow for greater flexibility. Overall, I think load balancers are a great fit for microservices and container-based application, for example, Docker and Amazon ECS, but also for Amazon EC2, as we'll see in this lecture. Finally, there is a port mapping feature that basically the load balancer can redirect to any dynamic port in the backend, and this is what allows the load balancer to basically redirect to the same instance on the application running on the same machine. In comparison, if you wanted to run 5 microservices before using a classic load balancer, you would need 5 classic load balancer, and that was very expensive and inefficient. Now we have an application load balancer. You can use one load balancer fronting 10 applications if you wanted to, and that works great. So as a diagram, how does that look like? Well, we have HTTP best traffic, and so we have our external application load balancer, V2, and basically there's going to be a target group, and maybe our first application is the user's application. So we have our target group, and we have EC2 instances, and we also define a health check to make sure that these instances are healthy. And so our load balancer will basically direct the HTTP based on the root. So if a user comes and say, I want the root/user, then the load balancer says, okay, I'm going to redirect to that target group on the right-hand side and to the instances that are healthy. Additionally, we can set up a second target group, maybe for the search application. And we have the same concept. We have many EC2 instances, and we have health checks defined on them to make sure they're healthy or not. And if the user requests a /search root, the external application load balancer will basically redirect to the search target group. And so that's the idea. You can have as many target groups as you want as behind your ALB. And then what happens is that in each target group, you can have as many EC2 instances as you want, and you can have health checks checking the status of these instances. So what's good to know for ALB? Well, you can enable stickiness at the target group level. So that means that the same user always goes to the same instance. And basically the stickiness will be generated by the ALB. So it'll add a cookie at the ALB level, not the application. You have nothing to do in your application. ALB supports 3 things. It supports HTTP, HTTPS, and WebSockets protocol. And the application servers don't see the IP of the client directly. So that's a very, very common and popular question at the exam as well. Basically, the true IP of the client is inserted in one header called X_for header. And if you want to still get the port, you can get X_forwarded port and X_forwarded proto. So you may be asking, how does it look like? Well, basically, we have our client IP, 1, 2, 3, 4, 5, 6, 7, 8, and it talks to our ALB. And what happens is that the ALB does something called a connection termination. So it'll establish a new connection to your EC2 instance. So your EC2 instance sees the private IP of your load balancer. It doesn't see the private IP of the client. And for your EC2 instance to see the IP of your client, so 1, 2, 3, 4, 5, 6, 7, 8, then it needs to look at the header X_for. And this is how you get it. And this is a very popular question at the exam. Now, if we look at network load balancers, they're layer 4, and so they're a bit lower level, and it's for TCP traffic. Okay, so before it was layer 7 HTTP traffic, now it's layer 4 TCP traffic. And network balancers are deemed to be super high performance, so this is how they're advertised, and they can handle millions of requests per second, and they support static and elastic IP. They have less latency, so 100 milliseconds versus maybe 400 milliseconds for ALB. Those are ballpark numbers. And they're most commonly used for extreme performance, and probably won't be the default load balancer you'll choose overall. But this is the exact same process as the application load balancer. And so if we look at the diagram, well, we get the exact same diagram as before, but now instead of HTTP traffic, we're talking about TCP traffic. And that's simple. The TCP network and traffic will be routed to different target groups. So that's about it. Network load balancer, just remember, it's higher performance. Now, good to know, the classic load balancers, as I said, are deprecated. Now you want to use the application load balancer for HTTP and HTTPS and WebSockets, and you want to use the network load balancer for TCP. The CLB and ALB, so classic load balancer and application load balancer, support SSL certificates and provide SSL termination. All load balancers will have a health check capability. The ALB can route based on the hostname and the path. The ALB is a great fit with ECS or Docker. Also, all these load balancers, classic load balancer, application load balancer, and network load balancer, they have static host names. That means that basically we get a URL, as we'll see in the hands-on in the next lecture, we'll get a URL, and that will be the rest of the time the URL that our application will use. We should not resolve that URL and use the underlying IP. That is also a very popular question. Load balancers can scale, but not instantaneously. So basically, if you expect a massive load, like a lot of load and it's expected for you, you should contact AWS for them to warm up your load balancer so that they scale with you. NLB, as opposed to ALB and CLB, they see directly the client IP on the application side, so there is no X forwarded for proto header before, but that's just for network load balancers. And then you should know that 4xx type of error are client-induced errors, and 5xx type of errors are application-induced errors. If you get a 5 or 3, that means that your ELB has no more capacity or no registered targets. And if the load balancer cannot connect to your application, then you should check your security group. So I'm aware that was a very heavy lecture and lots of knowledge right here. Don't worry, we're going to go into a hands-on lab in the next lecture to practice this. But just remember, we have 3 types of load balancer. One is deprecated, and the most common ones you're going to see at the exam is going to be the ALB, application load balancer. Don't forget about stickiness, don't forget about health checks and target groups. Okay, hope that was helpful. I will see you in the next lecture.